Imagine this. Somewhere in the endless dark, there's another world. A world wrapped in clouds, cradled by sunlight. A world where oceans might glimmer, where forests might breathe, and where someone, might be looking back. For decades, we've stared at the night sky and wondered, are we alone? It's the oldest question humanity has ever whispered into the void. And for just as long, the void has whispered nothing back. Until now. NASA has found a planet not just similar to Earth, but so close, so hauntingly familiar, that scientists call it Earth 2.0. Its name is Kepler 452b, and according to the models, it carries a 99.8% chance of life. Stop for a moment. Let that number echo in your mind. 99.8%. Not just maybe, not just possibly, but almost certain. This isn't science fiction. This isn't a distant dream. This is real data, real signals from a real world circling a distant sun-like star 1,400 light-years away. And it could be the single most profound discovery in the history of our species. We call it a super-Earth, a world slightly bigger, slightly older, perhaps slightly wiser than our own. While our ancestors were carving tools from stone, this planet was already glowing under its ancient sun. While our species struggled to crawl from caves, this world may have already known the touch of life. What if we're late to the party? What if life began there long before it began here? What if they've been waiting? But there's a twist. The closer we look at Kepler 452b, the stranger it becomes. Its age, its distance, its eerie resemblance to home. It's like staring into a mirror that's tilted just a little toward the future. And if what we suspect is true, then this lonely blue speck in the darkness might not be lonely at all. Tonight, we journey there, across 1,400 light-years, beyond the familiar warmth of the sun, into the orbit of a star called Kepler 452, where something extraordinary may already be unfolding. We'll see how this world was found, why it's almost identical to our own, and what it would mean if we are not the first spark of life to awaken in this galaxy. Because if life truly exists there, everything we know about existence is about to change. So, join us as we peel back the darkness to glimpse another Earth, a second cradle of life, drifting silently among the stars. Before we can understand how extraordinary Kepler 452b might be, we need to understand just how delicate the recipe for life truly is. Earth is not simply a rock drifting through space. It is a perfect balance of cosmic coincidences, an island of order suspended in chaos. Every breath we take, every drop of water that ripples across our oceans, every tree that reaches for the sky, exists because countless conditions aligned in just the right way, at just the right moment. Earth orbits within what scientists call the habitable zone of the Sun, a narrow ring around a star where temperatures are neither too hot nor too cold, where water can remain liquid. Too close, and oceans boil away into choking steam. Too far, and seas freeze into silent ice. We hover in the slim golden band between fire and frost, and that thin balance is why life exists at all. But proximity to a star is just the beginning. Our planet spins at exactly the right speed, not so fast that violent winds tear across the surface, not so slow that one side burns while the other freezes. This rotation gives us our 24-hour days, stirring the atmosphere and creating weather patterns that distribute heat and moisture across the globe. We are shielded by an invisible magnetic field that deflects deadly radiation from space. This magnetosphere, generated by molten iron churning in Earth's core, wraps around our planet like a cosmic umbrella. Without it, solar wind would strip away our atmosphere molecule by molecule, leaving us as barren as Mars. The aurora borealis, those dancing curtains of light at our poles, are actually the visible traces of this shield at work. Our atmosphere itself is a masterpiece of balance. 78% nitrogen provides stability. 21% oxygen fuels complex life. Less than 1% carbon dioxide traps just enough heat to keep us warm. Too much carbon dioxide, and we become Venus, a hellish furnace. Too little, and we become a snowball, locked in eternal winter. Even our moon plays a crucial role. Its gravitational pull stabilizes Earth's axial tilt, preventing wild climate swings that could wipe out life before it takes hold. The moon creates our tides, churning the oceans and perhaps providing the rhythmic environment where the first organic molecules learned to replicate themselves. Water covers 71% of our surface and exhibits unique properties that make life possible. It's the only substance that expands when it freezes, causing ice to float rather than sink. This means our oceans don't freeze solid from the bottom up, preserving liquid water beneath ice even in the coldest winters. Even our massive neighbour, Jupiter, acts as a cosmic guardian, using its gravity to deflect wandering asteroids and comets that could otherwise wipe our world clean. Without Jupiter's protective influence, Earth would be bombarded by space debris far more frequently. Our star itself is unusual. Most stars in the galaxy are red dwarfs, dim, long-lived, but prone to violent flares. Our Sun is a G-type star, stable and bright, providing steady energy for billions of years. The very elements that make up our bodies were forged in the hearts of dying stars and scattered across the galaxy when those ancient suns exploded as supernovas. It's easy to forget how fragile all this is. Earth feels eternal beneath our feet, but in the scale of the universe, it is a candle flickering in an endless storm. Life as we know it exists because of a fragile, intricate dance, a balance so precise that even the slightest shift could erase everything we are. This is what makes Kepler 452b so haunting, because from what we've seen, it appears to have followed the same choreography. It sits in the same delicate band of starlight. It orbits a star uncannily similar to our own, and it may hold the same rare ingredients that sparked our existence. So the question becomes unavoidable. Is Earth truly unique, or just the first one we happened to find? Until recently, the search for another Earth felt almost mythical, like chasing a mirage on the horizon of the galaxy. For centuries, we could only dream of other worlds. Ancient philosophers imagined them. Science fiction writers populated them. But we had no way to know if they truly existed beyond the reach of our solar system. The first confirmed exoplanet wasn't discovered until 1992, orbiting a pulsar, a dead star spinning so rapidly it swept beams of radiation across space like a cosmic lighthouse. This was no place for life, but it was proof that planets existed beyond our sun's influence. The real breakthrough came in 1995 when astronomers announced the discovery of 51 Pegasi b, the first planet found orbiting a sun-like star. This world was a hot Jupiter, a gas giant orbiting so close to its star that a year lasted only 4 days. Its surface temperature reached over 1,000 degrees Celsius, but it shattered our assumptions about planetary systems and opened the floodgates for discovery. The early years of exoplanet hunting revealed mostly extreme worlds. We found planets where it rained molten glass, where diamonds fell from methane skies, where one side was locked in eternal day while the other froze in perpetual night. We catalogued thousands of barren rocks, scorched gas giants, and frozen wastelands. worlds of fire and glass, of storms and silence, each one a reminder of how rare and fragile our planet truly is. Everything changed with the Kepler Space Telescope. Launched in 2009, Kepler was humanity's most ambitious planet-hunting mission. Unlike ground-based telescopes that had to peer through Earth's shimmering atmosphere, Kepler floated in space, watching over 150,000 stars with unwavering precision. Kepler's mission was simple in concept, but revolutionary in execution. Stare at one patch of sky and measure the brightness of each star with incredible accuracy, looking for the tiny dips that occur when planets transit across stellar faces. The telescope could detect changes in starlight of just 0.01%, equivalent to measuring the dimming caused by a flea crawling across a car headlight from several miles away. Over 4 years, Kepler collected over 3.4 terabytes of data. Computer algorithms sifted through this ocean of information, looking for periodic dimming patterns that revealed planets. The discoveries were breathtaking in their diversity. Kepler found super-Earths, rocky planets larger than Earth but smaller than Neptune. It discovered mini-Neptunes wrapped in thick atmospheres. It revealed tight-knit planetary systems where multiple worlds orbited closer to their star than Mercury does to our Sun. But the most tantalizing discoveries were the potentially habitable worlds. Kepler 22b, announced in 2011, was the first confirmed planet in the habitable zone of a Sun-like star. Kepler 186EF followed, the first Earth-sized planet found in the habitable zone, though around a much dimmer red dwarf star. Statistical analysis of Kepler's data revealed that roughly 20% of Sun-like stars host Earth-sized planets in their habitable zones. In our galaxy alone, that translates to billions of potentially habitable worlds. The universe suddenly seemed less lonely, but also more daunting. With so many possible homes for life, why hadn't we heard from anyone? And then, something impossible appeared. Hidden in a stream of dim starlight, orbiting a distant sun-like star called Kepler 452, scientists detected a faint, rhythmic flicker, a shadow passing across its star every 385 days. That shadow was not a trick of light. It was a world, a planet just slightly larger than Earth, circling within its star's habitable zone. They named it Kepler 452b, July 23, 2015, a date that will be remembered as long as humanity reaches for the stars. At NASA's Ames Research Center, researchers gathered around computer screens, displaying data that would rewrite our understanding of our place in the universe. After years of sifting through signals from the Kepler Space Telescope, they had found something unprecedented. A planet so remarkably similar to Earth that it defied the odds. The discovery began with a pattern hidden in noise. Kepler 452, a G-type star located 1,400 light-years away in the constellation Cygnus, had been under observation since the telescope's mission began. Every 30 minutes for over 3 years, Kepler measured the star's brightness with extraordinary precision. Buried in that data were tiny periodic dips in brightness, dips so small they represented a change of less than 0.01%. Dr. John Jenkins, the lead data analyst for the Kepler mission, had seen thousands of these transit signals. Most turned out to be false positives, but this signal was different. It repeated every 385 Earth days with clockwork precision. The depth of the transit suggested a planet roughly 1.6 times Earth's diameter, and most remarkably, the orbital distance placed it squarely within the habitable zone of its sun-like host star. The team spent months verifying the signal. They ruled out binary star contamination, analysed the star's spectrum to confirm its sun-like nature and used computer models to simulate the planet's probable characteristics. Every test confirmed what they hardly dared to believe. They had found the most Earth-like exoplanet ever discovered. Kepler 452b is about 60% larger in diameter than Earth, placing it in the category astronomers call a super-Earth. This size suggests stronger surface gravity, perhaps 20 to 50% stronger than ours, significant enough to feel but not crushing to Earth-like life forms. More importantly, planets of this size are more likely to retain thick atmospheres and maintain geological activity over billions of years. The planet's orbit is almost eerily familiar. At 385 days, its year is only 20 days longer than Earth's. This orbital period places it at an optimal distance from Kepler 452, where liquid water could exist on the surface. Computer climate models suggest that if Kepler 452b has an Earth-like atmosphere, surface temperatures would be suitable for liquid water across much of the planet. Perhaps the most remarkable aspect was the nature of Kepler 452 itself. Unlike many exoplanet host stars, which are dim red dwarfs prone to violent flares, Kepler 452 is a G2V star, exactly the same spectral type as our Sun. It has 96% of our Sun's mass and 110% of its luminosity. Its surface temperature differs from the Sun's by less than 100 degrees Celsius. There is one crucial difference: age. Kepler 452 is approximately 6 billion years old, making it about 1.5 billion years older than our 4.6 billion-year-old Sun. This age difference has profound implications. While life on Earth was still learning to photosynthesize, life on this distant world, if it ever arose, could have been evolving complex multicellular forms. Dr. Kepler Barucki, the principal investigator of the Kepler mission, called it the closest thing to another place that somebody else might call home. NASA Administrator Charles Bolden declared it might be humanity's bigger, older cousin. The media dubbed it Earth 2.0. Using sophisticated climate models that account for atmospheric composition, greenhouse effects, and stellar evolution, researchers calculated that Kepler 452b has the potential to be habitable for most of its history. The older, slightly brighter star means the planet receives about 10% more energy than Earth, enough to keep it warm even with a thinner atmosphere. Most remarkably, the team calculated a 99.8% probability that conditions on Kepler 452b are suitable for liquid water to exist on its surface. This wasn't based on direct observation, but on statistical analysis of thousands of climate simulations using different atmospheric compositions and surface conditions. In nearly every scenario they tested, at least some portion of the planet's surface maintained temperatures where water remains liquid. The discovery represented more than just another exoplanet. It was validation that Earth-like worlds exist around Sun-like stars. After finding thousands of bizarre and exotic worlds, astronomers had finally discovered a planet that felt familiar. A world where we could imagine walking under alien skies that might look remarkably like our own. But familiarity brought its own haunting questions. If Kepler 452b is so similar to Earth, why don't we see any signs of the civilization that might have had a billion-year head start on us? To understand the magnitude of Kepler 452b, we have to go beyond its poetic nickname of Earth 2.0 and examine what the data truly tells us. Because behind that simple designation lies one of the most remarkable planetary portraits we've ever assembled from across the void. Kepler 452 represents a cosmic coincidence so remarkable it seems almost scripted. In a galaxy containing over 400 billion stars, most of which are dim red dwarfs or massive short-lived giants, finding a near-perfect solar twin is extraordinarily rare. G-type main sequence stars like Kepler, 452, and our Sun comprise less than 10% of all stars in the Milky Way. The star burns hydrogen at almost exactly the same rate as our Sun, maintaining the steady, reliable energy output that complex life requires. Its surface temperature differs from the Sun's by less than 0.5%. Any hypothetical observers on Kepler 452b would see their star as the same familiar golden disk that has illuminated human civilization. But there is that haunting difference: age. As hydrogen fuel in a star's core gradually depletes, the star slowly brightens and expands. Kepler 452, at 6 billion years old, has been burning 1.5 billion years longer than our Sun. This extended lifetime has caused it to brighten by about 10% compared to our Sun's current output. This brightness increase creates what astronomers call the aging star paradox for habitability. As Kepler 452 has grown brighter over billions of years, its habitable zone has gradually moved outward. However, planets aren't passive recipients of stellar energy. They have feedback mechanisms that can maintain habitability over geological timescales. Earth demonstrates this. Our Sun has brightened by 30% since life first appeared 3.8 billion years ago, yet liquid water has persisted. The secret lies in the carbon cycle. Increased solar heating causes more water to evaporate, increasing rainfall and rock weathering. This weathering removes carbon dioxide from the atmosphere, reducing the greenhouse effect and cooling the planet. Kepler 452b, if it has similar geological processes, could employ the same natural thermostat. The planet's size plays a crucial role in habitability. At 1.6 times Earth's radius, Kepler 452b has 2.6 times Earth's surface area and, assuming similar density, about 4.1 times Earth's mass. This larger mass creates important advantages. Stronger gravity helps the planet retain its atmosphere over billions of years, preventing the gradual loss to space that has left Mars nearly airless. Larger planets also maintain geological activity longer. A planet with 4 times Earth's mass would contain 4 times as much radioactive material and would cool more slowly. This means Kepler 452b likely maintains active volcanism and plate tectonics today, recycling carbon and regulating climate through the carbon cycle. The stronger surface gravity, roughly 40% higher than Earth's, would noticeably affect any life that evolved there. Hypothetical visitors from Earth would feel significantly heavier, though not crushingly so. This gravity might favor different evolutionary pathways: stronger bone and muscle structure in vertebrate-like creatures, perhaps more robust plant stems to support growth against increased gravitational pull. We cannot yet determine many crucial characteristics. The planet's rotation period, the length of its day, profoundly affects climate and habitability. Earth's 24-hour rotation creates our familiar day-night cycle and drives global circulation patterns. A much slower rotation could create extreme temperature differences between day and night sides. A much faster rotation could generate more violent weather systems. The atmospheric composition remains the greatest mystery. If Kepler 452b has retained an Earth-like atmosphere, it would likely contain nitrogen, oxygen, and trace amounts of other gases, including water vapor. Oxygen would be the most exciting discovery, as it's almost certainly a biosignature, evidence of photosynthetic life actively producing this reactive gas. Water itself remains undetected but probable. the building blocks of water are among the most abundant elements in the universe. The question isn't whether Kepler 452b has water, but how much and in what form. Climate modelling suggests that with its slightly higher stellar flux and potentially thicker atmosphere, it might be an ocean world with vast interconnected ocean systems. What we do know with confidence is this: Kepler 452. b represents the most Earth-like world ever discovered. It orbits in the habitable zone of a Sun-like star. It receives energy levels compatible with liquid water. Its size suggests it can retain a thick atmosphere and maintain geological activity. Statistical models give it a 99.8% probability of harboring conditions suitable for life. But statistics are not the same as reality. And reality, when it involves a world 1,400 light-years away, remains tantalizingly beyond our reach. If Kepler 452b truly holds the ingredients for life, then the most unsettling question becomes impossible to ignore. What if something is already there? Life on Earth took nearly 1 billion years to emerge after our planet's formation. Another 1 billion years for cells to become complex, and almost 3 billion more years for multicellular life to diversify. Evolution is patient, working across timescales that dwarf human civilization. Yet, if Kepler 452b has had an extra 1.5 billion years under the warmth of its ancient star, then whatever arose there may have had time not just to crawl, not just to think, but to transcend. We tend to imagine alien life as something strange, monstrous, unrecognizable, but life anywhere must obey the same universal laws: chemistry, evolution, competition, survival. If conditions on Kepler 452b are truly similar to Earth's, then perhaps the results are not so different either. Carbon remains the most versatile foundation for complex chemistry. Its ability to form 4 stable bonds allows for the intricate molecular architectures that life requires. Water would serve as the universal solvent, the medium where all biological chemistry occurs. Evolution would follow similar patterns: random mutations creating variation, environmental pressures selecting for successful traits. With a 1.5 billion year head start, Kepler 452b's hypothetical biosphere could be anywhere from slightly more advanced than Earth's to unrecognizably sophisticated. If life there followed a timeline similar to Earth's, it would have achieved complex multicellular forms around the same time Earth was still dominated by simple bacteria. While our ancestors were learning to use tools, their civilization might have been reaching for the stars, but evolution doesn't follow a predetermined path. Random events, asteroid impacts, volcanic catastrophes, climate shifts can redirect the entire course of biological development. Perhaps their dinosaur equivalents never went extinct, evolving intelligence over hundreds of millions of years. Perhaps entirely different kingdoms of life emerged, following biochemical pathways unknown on Earth. The planet's physical differences would shape evolution in subtle but important ways. Stronger gravity might favor different body plans, perhaps creatures with more robust skeletal systems, or organisms that never left the oceans where buoyancy counteracts gravitational pull. The slightly brighter star might drive photosynthesis along different pathways, creating ecosystems with different energy flows. The possibility of intelligence arising on Kepler 452b raises profound questions. On Earth, intelligence appears to have evolved only once among animals, in the lineage that led to humans. This suggests that while life might be common, intelligence might be rare. The chain of evolutionary events that led to human consciousness involved numerous unlikely steps. Yet the long timescales available on Kepler 452b increase the odds that intelligence might eventually emerge. Even if consciousness-level intelligence is a 1 in a million evolutionary outcome, a billion extra years provides many opportunities for those unlikely events to occur. Multiple lineages might have developed intelligence independently. If intelligence did arise on Kepler 452b, what form might it take? Human intelligence is shaped by our evolutionary history as social primates. Alien intelligence might be fundamentally different, perhaps distributed across multiple individuals like a hive mind, or embodied in entirely different sensory and cognitive systems. The time factor becomes especially significant when considering technological development. Human civilization developed from agriculture to spaceflight in fewer than 10,000 years. If intelligence arose on Kepler 452b8 even a few million years ago, their technology could be incomprehensibly advanced by our standards. Or perhaps they face challenges we haven't encountered. Different planetary conditions might have made certain technologies difficult or impossible to develop. Intelligence doesn't guarantee technological advancement along the same lines as human development. Such ancient minds might have transcended the biological forms that originally evolved on their world. Perhaps consciousness long ago migrated into artificial substrates, becoming immortal digital entities. They might have merged with their technology so completely that the distinction between living and artificial intelligence became meaningless. Yet perhaps the most unsettling possibility is not that intelligence arose on Kepler 452, but that it arose and then disappeared. Even intelligence might be temporary. Climate change, asteroid impacts, volcanic catastrophes, or simply the inevitable evolution of their star could have ended any civilization that developed there. And yet, silence. We have heard nothing. No signals, no transmissions, no shimmering evidence of minds at work. This is the paradox that haunts every search for life, the Fermi paradox. If the universe is filled with habitable worlds like Kepler 452b, if life is common and intelligence eventually emerges, why is it so quiet? Maybe life is fragile. Maybe intelligence is fleeting. Maybe every world eventually burns itself quiet. Or perhaps they are still there and simply watching, silent, patient, waiting for the moment when the faint flicker of our world reaches their skies. Because right now, as we speak, the light from our sun is still on its way to Kepler 452b. If intelligent eyes are looking back at us, they are seeing Earth as it was 1400 years ago, before electricity, before telescopes, before we even knew what stars were. To them, we are still shadows in the dawn. In about 1400 years, if patient observers on Kepler 452b are watching our sun, they will see the first signs of industrial activity on Earth. And then, perhaps, they might finally have reason to turn their attention toward our small blue planet and discover that they are not alone. Kepler 452a may not just be another planet. It may be the mirror where we glimpse our own destiny, or our own extinction. Either way, if life truly lives there, then for the first time in human history, we are not alone. Standing on our small blue world, it's easy to believe we are the center of everything. We build our cities like monuments against the void. We name the stars as if claiming them. And yet the truth is humbling. Earth is a fragile flicker adrift in an ocean of darkness. And now, out there in that vast silence, we may have found another flicker. One that burns just as bright, but has been shining far longer. Kepler 452b is more than a scientific discovery. It is a temporal mirror held up to our entire existence, reflecting not just what we are, but what we might become. If life exists there, then life is not rare. It is not a miracle. It is a natural consequence of the universe itself, a spark that ignites wherever the conditions are right, no matter how far apart those sparks may be scattered across the cosmic dark. This changes what it means to be human. It reframes our story from something isolated and exceptional to something woven into a grander cosmic tapestry. We are not an accident. We are a chapter. One among countless others being written on countless other worlds, each following the same fundamental laws but telling unique stories shaped by local conditions and the patient work of evolution across deep time. The age difference between our worlds adds profound dimension to this cosmic perspective. If intelligence arose on Kepler 452b, it has had time to mature in ways we can barely comprehend. While our species was learning to make fire, their descendants might have been harnessing the energy of stars. While we carved our first tools from stone, they might have been carving new worlds from cosmic dust. This temporal displacement forces us to confront our own future more clearly. Kepler 452 represents what our sun will become, slightly brighter, gradually expanding as it ages, eventually making Earth uninhabitable. If life on Kepler 452b has survived this stellar evolution, then perhaps there is hope for our own long-term survival. The possibility of ancient intelligence on Kepler 452b also raises questions about cosmic perspectives. A civilization with millions or billions of years of history might view the universe on timescales we can barely comprehend. They might pursue goals and projects that span geological ages, working toward objectives that require patience measured in eons. Such ancient minds might have transcended biological forms entirely, becoming immortal digital entities that experience reality in ways purely biological intelligence never could. They might have learned to manipulate space-time itself, to create artificial worlds, or to upload consciousness into substrates that last geological ages. Yet the silence from their direction suggests either that such advanced civilizations don't exist, don't communicate in ways we can detect, or have moved beyond the need for electromagnetic signals entirely. Perhaps truly advanced intelligence communicates through methods we haven't discovered: quantum entanglement, manipulation of fundamental forces, or information channels woven into the structure of space-time itself. The study of Kepler 452b also reveals how special Earth's position in time might be. We exist during a particularly favorable period in cosmic history. Star formation has slowed compared to earlier epochs, but the heavy elements necessary for rocky planets have had time to spread throughout the galaxy. We inhabit what astronomers call the stelliferous era, the age when stars shine brightly and provide energy for complex chemistry and life. As potentially one of the earlier intelligent species in our galaxy, we might serve as ancestors or guides for civilizations that develop later. The technologies we create, the knowledge we preserve, the values we embody could influence the development of intelligence across vast regions of space and time. The search for life on Kepler 452b thus becomes more than scientific curiosity. It represents our attempt to understand our place in the cosmic story and our role in the universe's future. Are we pioneers in the development of galactic intelligence, or late arrivals to a galaxy already shaped by ancient minds? These questions will likely remain open for decades or centuries to come. The technologies needed to detect life on distant exoplanets are only beginning to develop. Even confirming the presence of oxygen or other biosignatures in Kepler 452b's atmosphere would require unprecedented precision in our telescopes. Yet the search continues, driven by the fundamental human need to understand our origins and destiny. We stand at a unique moment in human history. For the first time, we have the technology to detect potentially habitable worlds around other stars. For the first time, we can seriously contemplate discovering life beyond Earth within our lifetimes. For the first time, we can imagine ourselves not as isolated inhabitants of a unique world, but as members of a cosmic community. Kepler 452b represents our current best hope for finding evidence of life beyond Earth. Whether that evidence comes as atmospheric biosignatures, radio signals, or simply confirmation that another Earth-like world has maintained habitable conditions for billions of years, its discovery will mark a watershed moment in human history. The universe suddenly seems less lonely, but also more daunting. With so many possible homes for life, the silence becomes more profound and more mysterious. Yet that silence may be temporary. As our technology improves, we edge closer to the day when the universe's long quiet might finally be broken. We began with a question, a whisper into the void. Are we alone? For centuries, that question has defined our search of the stars. It shaped our myths, our science, our restless curiosity. And now, across the silent dark, we may have found our first answer. Kepler 452b waits 1,400 light-years away, circling its ancient star, glowing softly in the constellation Cygnus. We do not yet know if oceans shimmer beneath its clouds or if minds gaze back from alien shores. We do not know if forests sway under skies that might look remarkably like our own, or if cities rise toward stars that have been watching over that world for billions of years longer than they have watched over ours. But we know this: it is real. A world like Earth, born of the same cosmic laws, balanced in the same delicate dance of distance and light. A place where the same chemistry that sparked life on our world could have awakened consciousness under alien suns. A world where liquid water could flow, where atmospheres could breathe, where the long patience of evolution could work its transformative magic across deep time. And in that possibility lies something greater than discovery. It is hope. Hope that we are not a fragile accident adrift in an empty universe, but part of a pattern written into the cosmos itself. Hope that life is not rare, but inevitable wherever conditions allow. Hope that consciousness is not unique to Earth, but a natural consequence of complexity and time. The statistical models give Kepler 452c a 99.8% chance of harboring the conditions necessary for life. That number represents more than scientific calculation. It represents the mathematical expression of one of humanity's deepest dreams, that somewhere among the stars, other worlds have followed the same path, from chemistry to biology to consciousness, that we have traveled on Earth. Even if Kepler 452b proves to be sterile, the search itself has already changed us. We have learned that planets are common throughout the galaxy. We have discovered that many orbit within the habitable zones of their stars. We have found that the ingredients for life exist in abundance throughout the cosmos. The universe is not empty. It is filled with worlds, and many could be homes for life. This knowledge reshapes our cosmic perspective. We can no longer see Earth as the sole stage for the drama of existence. Instead, our world becomes one of countless theatres where the play of evolution unfolds, each following the same fundamental script, but adding unique variations. The search for life on Kepler 452b continues as our technology advances. The James Webb Space Telescope and future instruments will probe deeper into the atmospheres of distant exoplanets, searching for chemical signatures that would reveal active biology. Each new observation brings us closer to answering the fundamental question of our cosmic solitude. But regardless of what we discover, the search itself has already transformed us. We have become a species capable of detecting worlds around distant stars. We have developed the intellectual tools to analyze the habitability of planets we will never visit. We have begun to see ourselves as part of a larger cosmic community. If we are alone, then consciousness becomes even more precious, a rare phenomenon that deserves our protection. If we are not alone, then we become part of something larger than any single world or species, participants in the universe's grandest experiment. So, we return to where we started, staring up at the night sky. But tonight, it feels different, because somewhere out there, another Earth might already be spinning through the dark, carrying its own oceans, its own forests, its own possibilities. Maybe one day we will develop the technology to visit that distant world, to walk under alien skies that might feel surprisingly familiar. Until then, we keep searching. We build better telescopes, develop more sensitive instruments, and refine our understanding of what makes worlds habitable. We listen for signals from distant civilizations and prepare messages of our own for the day when contact becomes possible. Because if Kepler 452b truly carries life, whether simple or complex, ancient or young, familiar or wonderfully strange, then for the first time in human history, we are not alone. The universe, for all its vastness and apparent emptiness, becomes home to at least two worlds where matter has organized itself into forms capable of wonder, curiosity, and hope. Two worlds separated by immense distances, but connected by the shared miracle of consciousness arising from cosmic dust. In the end, Kepler 452 is more than a distant exoplanet. It is a bridge across the cosmic dark, a potential connection to intelligences we can barely imagine, and a mirror reflecting our own cosmic significance. It reminds us that we are made of star stuff, children of the universe's 13.8 billion year journey from simplicity to complexity. And if we are not alone, if life exists on that distant world or any of the billions of other potentially habitable planets in our galaxy, then the universe reveals itself to be even more magnificent than we dared imagine. Not just a collection of matter and energy following physical laws, but a creative force capable of producing the most remarkable phenomenon we know: conscious beings capable of love, discovery, and transcendence. The search continues. The questions remain open. But the mere possibility that another Earth spins silently among the stars has already begun to heal the cosmic loneliness that has haunted our species since we first looked up and wondered if anyone was looking back. Perhaps the most profound discovery is not that we might find life elsewhere, but that we have become the kind of species capable of looking for it. In our search for cosmic companions, we have discovered something equally remarkable: ourselves. If you made it this far into the video, we appreciate your support. If you enjoy space documentaries just like this, make sure to like and subscribe so YouTube will help push our videos into the algorithm. As always, we are open to feedback and suggestions for upcoming videos, so make sure to drop your thoughts in the comments below, and we hope to see you on our next video.